You're listening to the Banana Data Podcast, a podcast hosted by Data IQ. I'm Triveni.
And I'm Will.
And we'll be taking you behind the curtain of the AI hype, exploring what it is
and what it isn't
capable of. On this episode of the Banana Data Podcast, we're discussing the newest data initiatives in the NFL and how Spotify organizes its vast array of data.
Hey, Triveni, what's your favorite sport?
FIFA, but like on PlayStation, not in real life.
Okay, so not like a real sport, like an e-sport, but it's kind of like European football, yeah?
Yeah, well, it's football, but yes.
Football, exactly. Yeah. Cool. Well, that's somewhat related. I wanted to talk to you today about an article I found in The Ringer that's called The NFL's Quest to Quantify Quarterback Evaluation. And so this is about quarterbacks in American football. And I think it's something we haven't talked a ton about on this podcast, but just about, as it says in the title there, how we use data to evaluate athlete performance. And I think sports are somewhat interesting, though honestly, our focus on this podcast is more data and the value from data in business. But I think there are actually some interesting parallels and some lessons to learn that I want to dig into with you today.
Well, I mean, that makes sense, right? Sports, first of all, are a business, especially the way that they're run in the modern economy. But also, when you look at sort of the history of modern statistics and like where it's come from, a lot of folks who are now big names in the space got their start with baseball stats. So Nate Silver, of course, is one of these names who started off with evaluating baseball statistics and players, led to 538 blog, which then got sold back to ESPN. So it's this nice little circle of sports and data analytics, I think.
Yeah, and on that thread of, I think baseball was, at least to my mind, kind of the first sport to be revolutionized, to use a cliched term, by the use of data analytics. And I think if you think about baseball, it's very discrete, right? You have an at-bat, you have a pitcher, you have a batter. These actions are kind of zeros or ones, like you catch it or you don't catch it, you hit it or you don't hit it. And so in that way, the data lends itself well to being thought of in kind of tabular format. Like you could represent in some ways kind of a baseball game in a spreadsheet. So for that reason, I think baseball was easy with computational methods. It was easy with algorithmic methods to analyze and find insights from. And so what's so interesting to me about this article is that, the NFL is a little bit more of a fluid game, and particularly quarterbacks and the art of quarterbacking, it's kind of more fluid. And so therefore it's harder to describe with data and harder to analyze, but they're making some progress in that way.
Well, so how are they making progress, right? Because I guess there are binaries like pass completed, pass not, but there's also 11 players per team on the field. So I can't imagine that it's super simple.
So first of all, radio frequency chips are put now on individual players. So basically the pads of the players have these chips that are beaming back signals that's allowing analysts to record player speed, for instance, or how hard they get hit. So in this way, the data can be great in improving player safety. And then even more recently, the big one that I know other sports as well are implementing is the use of video analysis. So obviously the NFL has always put games on TV, but we haven't previously had, I think, the sophisticated capabilities we have now to use video streams and actually mine video streams and mine the data, quote unquote, in those video streams.
Yeah, I mean, I think to your point that the capacity to not only have all that video data, but then to actually use it using these deep learning methods that have come up in the past few years is a huge advantage to modern sports, right? Because there's plenty of TV and plenty of recordings everywhere. So it doesn't seem like having data is the problem anymore, right? It's more about how do you take that data and find something meaningful or figure out what to do with the data.
What I like about this article is they kind of frame it in like a old-fashioned way and like a futuristic way. The futuristic way is that, they're looking at advanced data streams and they're using advanced methods. So like you say, how do you find something meaningful in the data? Well, you use really sophisticated image processing algorithms to find something meaningful in an image that you couldn't do like 30 or 40 years ago. The more old-fashioned way, which I think is quite charming and still important to mention on a podcast like this, is just thinking intelligently about metrics. So for football fans out there, they talk about pass completion. So of the passes that a quarterback throws, how many are caught or completed by the receiver. And so there, obviously, higher is better. But when you're choosing metrics and choosing statistics to study, like, of course, if I just made a short pass to you, Triveni, every time we hike the ball, like it could be a really easy pass that was of little value to the team, but have a high completion rate. So I think that's an obvious point that like certain statistics can lie or mislead, but one they mention here. And so using these more mature techniques and getting above kind of those base level statistics is the way they're trying to think about quarterback evaluation and prediction of success.
Right. And so the end goal then is to be able to better evaluate a quarterback on the sort of X factor, right, which is going to be unearthed in the data to then say, okay, we want to definitely use this guy, or we want to train him in a different way, or we're going to go buy Tom Brady or whatever, right?
Yeah. So to find the X factor, or what really predicted or was predictive of a promising quarterback in the past, the way sports teams have solved this for decades is through the use of scouts, right? It's these men and women, it's their job to go out, watch college games, probably watch high school games, and say, hey, this Triveni, she's got something special. I think she's going to be good. And so I think an interesting point they raised in the article is, how can these algorithms, how can these data-driven methods, can they supplement, can they replace, can they be used with alongside scouts, which is another kind of thought that we see running throughout data and AI usage.
So it seems to me that actually, if the NFL and these teams want to move forward, they need to figure out how to make some sense of all of this data, right? Like, how do they pick through it? How do they figure out what's most relevant? So I think being able to understand and document all that is also going to be a big part of their next push.
Yeah, I think the NFL teams recognize this is necessary for them to compete, which is pretty cool. Because again, I think advancements made in the NFL, they're going to trickle down to other industries. But, we've talked in the past, like the first thing you need to be a data mature organization is just to have data records, right? Have your data lake, go and make sure that you're keeping track of what's happening in your organization so you have some system of record. If I'm a data scientist and I want to answer a question, there's a difference between the organization having data and me finding like thing that I'm going to analyze. And there's like a whole nother challenge too, which is, okay, say they say, Triveni, here's the video file from last night's game for the Broncos. We have the data, we're telling you where it is. But even then, like a video file is a lot of data when you're a data scientist sitting down and reading in a stream of bytes. How do you actually process a video file, and how do you understand behaviors that the quarterback is engaging in from a video file? I think if I had the answer to that question, I'd probably be working for the Denver Broncos analytics office, not talking to you, Triveni. But in general, this is me talking about data science in an optimistic way, because that's kind of the dream of a data scientist, is to show up, be given some pristine data set, and then said, hey, go find insights in this data set. Oftentimes, the reality of data science is that you don't have high quality data. You spend all your time kind of munging data, joining tables together, doing work just to get it ready for insight and analysis. So if we can move to this future that it sounds like the NFL is moving towards, where you have the data is good to go, it's of high quality, and now it's just the bright minds, it's their job to find insights and predict who the next Tom Brady is going to be. That's in the future I think I am excited for. Now it's time for that part of the podcast where we explain complex data science topics in plain English. So Triveni, could you explain to me graph databases, please?
Yeah. So when we think about a traditional database and the kind of databases that we're used to working with, what we're looking at are flat databases, right? Bunch of tables, basically rectangles of data, all stored somewhere in the cloud. And each rectangle has like a lookup key to the other one. So this table says, hey, this is the list of all the people. And over here is the list of all of their pet names, right? And so we have to do a lookup between the two tables to make sense of it. With graph databases, you don't actually have data stored in a flat relational way. It's actually about the network and I guess you say nodes of information, right? So if I'm looking at maybe like a social network for you, Will, I see that Will is at the center of this network and it's connected to Triveni and Anna and Jordan. And then each of those people have their own sort of set of people that they're connected to, which could be connected back to you or not. And so this is actually used in, graph databases are used in a lot of different use cases, but one of the big ones is actually fraud detection, right? So when you're looking at people attacking your internet backend, right? Or attacking one of your systems, they're often working in groups, right? So a ping from this bad IP is actually related in a relationship kind of way to another IP or to this user in this specific context. So the graph database is better at organizing and retrieving that complex relationship and network data than a traditional table structure.
Thanks for explaining that in English. Triveni, to that point about databases and data storage, I actually wanted to talk to you about an article that I read relatively recently that was written by some developers at Spotify. And it was about how they improve data discovery for their data scientists. And so I think there's a lot of interesting points that we can make about this article, but in general, just wanted to bring it to your attention and bring it to our listeners' attention, because the key idea here is that data discovery at Spotify is a real pain. And so they're building tools internally to help their data scientists discover and access data, I guess with an emphasis on discovered data.
So what you're saying is that there's so much data that the data scientists don't know what they have.
Exactly.
And if
so
you use this, okay.
Yeah, that's exactly right. And this is something that we see with a lot of our clients. I mean, in general, people talk about big data, and I think big data means something different than what we're referring to right now. More, this is like a mess of data, right? So if you're an organization, and Triveni was mentioning previously, kind of this concept of a data table. To get tables like that, you kind of have to know, like, what's the gold standard? What's the data that's update, that's high quality? And so in this case, like, just knowing the appropriate table to use can be complicated. And the point that Spotify engineers make in this article is that it's gotten even harder as they've moved to, in this case, the Google Cloud platform. They said that, quote unquote, it's led to an explosion of data set creation. And everybody's making tables. Someone's saying, like, this is my customer insight table. And then Triveni might be a data scientist who's working in the California office, and she's making her customer table. In reality, they're kind of recording the same insight about customers, and that duplication of data sets obviously can lead to lots of inefficiencies.
Okay, yeah. So I understand that. I think, I used to work in an organization that had a lot of information stored in both, sort of long and then wide format, or like at different levels of granularity. So it did feel like a lot of data was sort of repeated. But at the same time, each of those repetitions had a very like unique purpose, right? So just because this data originally was in wide format and I wrote a script to convert it to long, doesn't mean that we don't also need the long data stored somewhere.
True, different formats help. But again, I think the point here that they're going for and other organizations are going for is to say, hey, wide format, long format, those can both be valid. But what we don't want is both you and Anna, 2 days apart doing repetitive work. Once you've done something one and we think that it's kind of been signed off and is valuable to Spotify, we want that to be one and done. And then we want that just to be referenceable or searchable by other data scientists. I think that's what they're going for here. Yeah,
okay. I think that's fair. And I think that works at a place like Spotify where you're not dealing with very high sensitive data. But I do know I have a lot of clients in, again, the healthcare and financial industries where there's a real security issue, like to the point where it's row by row security for some of this information. And I'm sure they have duplication data sets all over the company, but because of sharing permissions and all the different sort of like privacy requirements, they actually can't use something like this to share data around.
That's a really great point. I hadn't thought about that. I would guess if you're a data scientist at Spotify, given that you're looking at relatively non-confidential things like listening history, it's kind of carte blanche. And so I get that the different data permissions could complicate this. Nevertheless, I think it's something that all organizations should and are starting to aspire to. People are talking about data lakes and data warehouses when people are starting to talk about big data, like having a place where my analysts can go to find data before we can start to improve business operations from it. But organizing it is still a real problem in 2020, I would say.
Yeah, especially because, it's a data lake, right? It's not a data shelf with like nicely organized catalogs of data. It's all dumped somewhere in your whatever cloud system you've decided. So organization and clarity, even like, honestly, like naming convention for tables, right? Those kinds of things, like that sort of organization can be very useful. And so I get why Spotify has gone this way. I will say I took a look at this and I thought it was so interesting. If you are a Spotify user, you get every week a new Discover Weekly, right? This is like, hey, we've been listening to a lot of this stuff, so we think you're going to like this. And they have the same thing here for data scientists, right? They call it low intent discovery, but basically, hey, here are some things that might be relevant to the work your team is doing or that you should be looking at based on other data sets you've looked at. So a sort of recommender system for data sets within the company, which I actually think is pretty nifty.
Yeah, no, I think that's totally right. Just to your point about naming conventions being valuable, like it's great, but it's hard to enforce. And you can even do it technically, right? That somehow you can say, I can write some rule that says, okay, you have to have like team name underscore project name. And if it doesn't fit in that format, we won't take it in our data store. But that's just a brittle solution. I think that what Spotify's done here, to your point, is very clever. It's just said, let's use, going back to our previous conversation, like network analysis to understand what are data sets that maybe your teammates are using, or what are data sets that are just highly popular within Spotify. And also, I thought it was fascinating. In the article, they mentioned that Lexicon, which is the name that they're giving this internal tool, has roughly 550 monthly active users, which is fascinating to me, right? So I work at a company that has 500 employees, and they have 550 monthly active users on a data table search system. So just kind of giving you a sense of how crucial data writ large is to their organization, which is kind of a separate but related conversation, which I found fascinating.
Yeah, how important it is, and like how much more important this kind of system is when you're at that kind of scale.
Another thing that this article made me reflect on is, why is Spotify doing this and other organizations aren't? Like, surely they're not the only company to have produced an in-house data tables search engine, which is how you could describe this. But not many companies are operating at this scale in this way. What do you think about Spotify is special? You mentioned one thing, and that they have probably lower data privacy restrictions than other organizations. But what are other limiting factors?
One, they just have so much data, right? So it's necessary to have something to organize all this. But even if you have a ton of data, most companies don't have the resources to actually in-house build out something like Lexicon, right? And so then they turn to other data cataloging systems or softwares to do that for them, which is necessarily going to be less nuanced than what Spotify has built for themselves, but at least can get those sort of teams started on that path towards better organization and eventual discovery.
Yeah, I think those are great answers. Hit the nail on the head. The one thing that I also think is relevant here is that, to your point, Spotify has a lot of data. I think one thing we haven't talked about, and it sounds cliche and kind of buzzy to mention it, but the concept of culture too, and that Spotify is a young company that my impression is that they've kind of from their inception said, we use data to power our product to give people Discover Weekly, which is one of their kind of niche offerings and core offerings. If you don't have this culture, you could still go out and buy other tools. Like I know Dataiku, Elation, there are other companies that offer data cataloging functionality, and they're good at what they do. But I guess what's interesting potentially for listeners to this podcast is just because you bought the tool, you need to think about how you can both upskill and kind of instill the values that users need to get the most value out of those tools.
Yeah, it's totally about building the tool, but then also enabling and empowering people to use it. Okay, before we head out, time for the banana riddle. So if you remember last week, I asked you, Will, to come up with an equation to make 2 2s equal to 5, right? You can only use the number 2 twice, nothing else, but any number of operators. So did you figure it out?
No, I have no idea.
All right, that's fair. It was a tough one. I wanted to get us started off on an insane note. So the answer is the square root of 0.2 to the power of -2. So 0.2 to the power of -2 is 1 over 0.04, which is 25. And the square root of 25 is 5. So there's that.
That was good. Triveni. There's a lot going on there. That's pretty good.
And we'll write out the answer in the show notes just in case that wasn't exactly clear. So then for next week or for next time, this one's probably a little bit easier. So I bought a baseball and a bat for a combined cost of $1.10, which is crazy in this day and age. But the baseball bat cost $1 more than the ball. So how much does the ball cost?
Let's see if I can figure that one out.
All right. We'll see you next week.
That's all we've got for today in the world of banana data. We'll be back with another podcast in 2 weeks, but in the meantime, subscribe to the Banana Data newsletter to read these articles and more like them. We've got links for all the articles we discussed today in the show notes. All right, well, it's been a pleasure, Triveni.
It's been great, Will. See you next time.